All right, here we go with problem number 1. On 1A, you have a function, well, it's really not a function, you have an equation there, and you're trying to show that the derivative equals that. So remember, they've given you the answer, so your algebra, you got to prove to them you know how to get there. So this is basically implicit differentiation. So I'm going to look at this equation and take the derivative with respect to x. So the x things will be normal for x. The y things, I have to remember to take the derivative with respect to x. So it's that whole chain rule involved. So I have 6y dy dx. When I look at negative 4x times y, I must remember that is the quotient, as a product rather. And so I'm going to do negative 4x as my first and y as my second. So I have first times the derivative of the second plus the second times the derivative of the first is negative 4 equals. And on this side, I just have 36, so the derivative of that is 0. Now I just have to do some algebra. I would probably, they're okay with you skipping some steps, but what I want to say is, you know, I would collect, you can do a couple steps in one. So I would think to myself, this one and this one I'm going to keep on this side, and I'm going to go ahead and factor it out. So they're okay with you doing that, 6y minus 4x. And then those other two I'll bring to the right. So this one, who was negative, would then become positive on the right, and like this. Perfect. Now, right here I want to say, what I don't want to see on your paper, you need to go to the next line. I mean, I know that you're dividing. They know that you're dividing. You don't have to show that. What I see a lot on this paper, on these papers, is people right here, they just go, oh, okay, there you go. That's what I get. Your two things are not equal anymore. So make sure that you're not doing that. You're going to the next line. They know that you're dividing. You don't have to show that you're dividing. I would have dy dx is equal to 4y minus 4x over 6y minus 4x. And of course, each of those numbers are divisible by 2. So I get down to exactly the order and everything of what they said. So point count, you got 1 point for doing implicit. So, you know, are you getting that dy dx? Are you, and you verify it correctly. So if you have a notation error, that's where you get a loss of a point. So if you, you know, if your two things didn't equal or whatever. All right, let's see if I can fit number 2 in here. We'll see. I might have to scrunch a little bit, but I might erase. I'll erase a smidge. All right, number 2. Nope, letter B. Letter B says find the slope of the tangent line. So your brain should say, I'm looking for dy dx. I just have to have, I've got a formula for dy dx. I just have to have an x and a y. At each point in the curve where x equals 6. So I'm going to go back to my original, and I'm going to plug in 6 for all the x's. So I know what all, I know that x is 6, but I would have to figure out, okay, that's great, but what's the y value? Now, you do have a calculator, so I mean, if you know, obviously I know you can do these numbers in your head, but if you wanted to check yourself, that's fine. I have 3y squared minus 24y, and I'm going to end up factoring, so I'm going to bring everything to the other side here. This would actually be 72, but you're going to subtract the 36, so I end up with 36, and I'm going to divide by the 3 to make my factoring easier. So y minus 6 and y minus 2 is equal to 0. Notice I keep writing equals 0. My work is very, very neat. So y equals 6 and 2. Now let me go back. So there's 2 points actually where x equals 6. Because again, this isn't a function. It's like a rotated conic section. And so there's 2 y values. So there's 2 different points. So you have to make sure that you're labeling really well. So notice my notation. dy dx at the point 6, 6, okay, equals what? I'm going to go back to this dy dx, and I'm going to put in 6 for x and 6 for y. Now, in reality, could you leave this like this? Absolutely. You would get full credit for that. This one's pretty easy because I can see the top is going to be 0 and the bottom's not. So that one's not too bad. I mean, I might put equals 0 because it's just so dadgum easy to see. However, over here, when I put dy dx at the point 6, 2, because remember we had 2 points, I'm going to try to squeeze it in here. Remember, it's 2y, that's really small, and 2x over 3 times y, which was 2, and 2 times x, which was 6. On this one, not so easy to see. I know you have a calculator, but they give you full credit for that right there. So personally, I'm just going to leave it like that. So there you go. Point count would be, on letter B, basically, there was 1 point for this one and 1 point for this one. So this, I mean, obviously you had to have that work to get those points, but that's what the point count was for, or where you got them. Perfect, perfect. I feel like I'm about to sneeze. I will sneeze while I erase. All right, told you. All right, let's look at part C. What does he have us do? Part C says, find the positive value of x at which the curve has a vertical tangent line. Show the work that leads to your answer. Again, a vertical tangent, what you should be thinking in your head, a vertical tangent is when the derivative is undefined, which means if you have a fraction, the bottom has to be 0. So I would always write this. And please look, AP's real picky about this. This is when 3y minus 2x equals 0, but the top doesn't equal 0. That is kind of this part, they're very picky about that because remember, if they both equal 0, that's the indeterminate form. And so the derivative not necessarily is undefined or 0, it's something else. It could be something else. So that, you probably didn't write that. My guess is, because that's a very tricky thing that's been mentioned very, very few times. But just kind of make that note in your head and get used to writing that. So if this question had said a horizontal tangent, that's when the top would be 0, but the bottom doesn't equal 0. So you have to kind of eliminate that indeterminate form. So I've got to figure out this. Now it's asking for the x value, so it'd probably be smart to, if I set that equal to 0, notice when I solve for y, I get 2/3 x. And then I'm going to plug that back into my equation. So 2x squared, the original equation, plus 3, and you could do this, of course, parentheses squared. You could do some simplifying as you go, if you'd like. Equals 36. And I've got to solve for x, right? So I'm just making sure I have the right thing here. So I have 2x squared. What is that? 4/3 x squared. And this would be 8/3 x squared is equal to 36. Again, you have a calculator. So, I mean, if you're terrible with fractions, add in your calculator. 2 plus 4/3 minus 8/3. I mean, if you have to do that, I'd rather you do that and get it correct than do it in your head and get it, incorrect. So that gives you 2/3 x squared is equal to 36. So x squared is equal to 54. And so the positive, when it said at what positive value, so I get the square root of 54. And point count wise, let's see, if you set 3y minus 2x equal to 0. That was worth 1 point. Again, if you don't write this, sometimes they may not give you credit, so that's why I want you to do that. And then you got 1 point for getting down to this correct answer of square root 54. Perfect. Let's do letter D. I think I'm going to have to erase for letter D. Y'all can get these points, guys. You can get these points. Might not get all of them, but you can get enough to pass, I promise, or enough to get your 5. Let x and y be functions of time that are related by that equation. So again, that equation there. And, okay, then it gives you all this stuff. The value of x is 2. The value of y is negative 2. dy dt is 4. Find the value of dx dt. So see how they threw in a related rate? Oh, goodness. How do you know it's a related rate? Remember when it's with respect to t. Okay, so this is at t equals 1. So I'm going back to this original function. I keep saying function. It's not a function, for heaven's sakes, Ms. Pruitt. That equation, and I'm going to take the derivative. Before I did it with respect to x because it was doing implicit, but now they've thrown in a related rate, so I have to take the derivative with respect to time, which has some similarities, but I have to remember when I do the derivative of the x things for x, I have a dx dt even with that one, where I did not have that in letter A. But there's a lot of similarities. So plus 6y dy dt. Now again, be careful here. Again, you can pull out a -4 and then do the product rule with x and y, or you can do the -4x and y, lots of different ways. I'm going to do it the same way I did it in part A because my brain just thinks that way. So first times the derivative of the second with respect to t plus the second times the derivative of the first, notice I have that dx dt now, is equal to 0. Again, some people like to solve for dx dt and get it with, clean it up and then plug in the numbers. You can do it both ways. I plug in numbers kind of immediately, and just be very, very careful, okay? Notice, I'm going to do some solving in my head, and that's going to help for some timing. X is 2, y is -2, and dy dt is 4. So 4 times x, that would be 8 dx dt, plus 6 times y, that's -12 dy dt, and -4x, just be careful, -8 dy dt, and then this one would be what, plus 8 dx dt, I believe, equals 0. So what do we have here? We have 16 dx dt's. I guess I could have plugged in for dy dt. I don't know why I didn't do that. But that's okay. I kind of did a little bit of both there. And I'm going to bring that over, because these are actually numbers. I don't know why I didn't plug in those numbers there. Let me do that. So as not to confuse you. I forgot to plug in for dy dt. So both of those, what was dy dt? 4. So 4 and 4. So I can have that number, what is that, -48 and -32. So if I pop that to the other side, 48 and 32 would be 80. So dx dt, I'm dividing by 16, would be 5. Now listen very carefully. If I wrote that like that, that would not earn me full credit for my answer, even though my number is correct. Because remember, if you write that notation, you're saying that dx dt is a constant at 5. So please, 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 you don't have to do it all in your work, but at the very end, when you have your final line, make sure you write dx dt evaluated at t equals 1. So you're indicating to your grader that you know dx dt is not always that. It happened to be that at t equals 1. So what the point count was is, did you use the product rule here? That was actually 1 point for using the product rule. And then did you did you do the correct derivatives with respect to t? So did you remember to put dx dt and dy dt? So it's kind of that same line. So the derivative with respect to t. Okay, I won't write that all out. And then the last point was the answer. But again, notation is a big deal. They take away, again, they for a notation point, notation error, they will not give you that point. So this is really, really big with related rates. You either write a sentence, kind of, when we did the word problems, it was just easier to say, you know, writing a sentence. This one's a little kind of weird. This would be a very long sentence. Or not really, you could say the value of dx dt at t equals 1 is 5. If you said that, that would be fine. So I'm just saying, if you leave it like this, make sure you have this notation. If you don't like that, if you think you're going to forget, write a sentence. So this would also give you full credit. I'm just going to show it both ways, and you can pick your fancy. So if I wrote dx dt is equal to 5, that's fine there, but I'm going to have a sentence. Look at what they ask you. The value, you're just restating the sentence. The value of dx dt at t equals 1 is 5. That would give you full credit as well. So one of the two. Got it? All right. Sweetness.